So on this 31, we've got a couple things going on here, but we're going to use the properties of logarithms. So let me just do a quick review. There's three properties. Three. 1, 2, 3. There's the plus property, or plus becomes multiplication. So if I have, what is that, log of A plus log of B, and it doesn't matter the base, they can, as long as they're the same base. And notice down here we have a base 10, so we'll do this as base 10. This is going to be log of A times B. Okay, and actually what we're being asked to do is to expand, so we're going to start with the multiplication, will become addition. So we see some multiplication down here. Okay, and then there's also the other rule that if we have log of A minus log of B, subtraction becomes division, A over B. And again, what we're going to do is we're going to expand this way, so when we see division we're going to make it subtraction. And then finally, if we have log of A raised to the B comes down in front, becomes multiplication, so an exponent becomes multiplying B log of A. Okay. Now there's three things going on here. One of the key things is that this little 3 is an index on this radical. That's going to make this a fractional exponent. It is not applied to the z. The z is actually to the first power. So that's the first thing you have to see, is the z is completely separate. Really easy to think of this as z to the third, but it's not. Okay, so what you really want to think of the y variable, it's really going to be y to the 2/3. Okay, that's a cube root. So this is a critical thing. So it's mixing a couple lessons, not only logarithms but radicals. Okay, the top, the numerator, is going to become, we're going to use sort of this idea of addition, and then anything that is in the denominator needs to be subtraction. So I'm going to do this in sort of one fell swoop. So the stuff in the bottom, the denominator, is going to be subtraction, stuff in the numerator. So the first thing I do is expand it out this way. Log of x to the 7, and that's going to be a sort of a positive. You're going to get minus log z and minus, I'm going to do it this way, 2/3, y to the 2/3. Okay, so what we've done is we've done sort of a combination of multiplication and division. Anything from the denominator, so like if I have log of A over B times C. Now we think, oh, times is addition, but since it's happening in the denominator, when this little guy expands, it's going to become log of A minus log of B minus log of C. Now, yes, if you want to think of it as addition, you can. That becomes log of A minus parentheses log of B plus log of C, and then this distributes through, so we get that negative. Okay, just to see that it works both ways, and we all have different ways of seeing it. We're not done yet though, because to expand the following expression, they want to expand it all the way. You may assume that all variables are positive. Okay, so the 7 comes down in front, so this is 7 log of x. There's a 1 here, so we bring it down in front, which we don't have to write that multiplying by 1, so that one's good. And then the 2/3 comes down in front. So that's logarithm property 3. We use kind of a combination. It doesn't seem like we really used the first one, but we sort of did, I guess. 2/3 log of y. So when you're finished, and there really should be parentheses around each of these inputs because logs are a function, right? So these all should, but sometimes we get a little sloppy and don't do that. You know, you should have all of these guys on, you know, but sometimes we just, like I said, I don't know if it's sloppy or just they kind of get in the way too. So this is our final answer. Okay, so watch that. Be careful about radicals. They are fractional exponents, so they're getting tested on two things here, which is keeping you on your toes. All right? Check in if you have any more questions. Thank you very much.